Hi, in this video we'll talk about the Projectile Motion SIMS software, which is a great simulation that physics teachers can use to illustrate and discuss the properties of projectile motion. If you're interested in seeing how you can get the Projectile Motion SIMS software, please go to Teachers Pay Teachers, and here is the URL that will take you there. Okay, let's start the software. There are three types of simulations dealing with the topic of projectile motion. The software includes extensive help in Word format that includes more detailed descriptions of each simulation, example questions, and lesson plans. The first two simulations illustrate projectile motion where the projectile is propelled horizontally. They are designed to answer questions like whether a dropped bullet or fired bullet will hit the ground first, and how the time to hit the ground is affected by the horizontal velocity of the projectile. Okay, let's take a look at horizontal cannon 1. Here you can see we have a cannon that is on a hill and will be fired horizontally. So we can shoot the cannon and start and stop it. You can see that the variable both for the drop ball and for the shot ball are shown in detail. We can also stop the motion every 1 second. We can also show a marker so that we can actually take and show very clearly that the two balls have exactly the same vertical distance at every point. We can hide or show the markers. And finally, we can add trails for every 1 second. In other words, we will show exactly where the balls are from second to second. Again, clearly illustrating how the vertical velocity and distance of the dropped ball and the shot ball are exactly the same. Okay, let's go back. We'll look at horizontal cannon 2. Okay, in this simulation, we are able to change the initial velocity, horizontal velocity of the ball. You have the same options for hiding the arrows. You have the same marker. You have the same stopping the ball every 1 second and showing the trails. So let's start at 13. And we can reset, and now we'll change the initial velocity, and we'll shoot. Now let me reset and actually show the trails. You can see that the marker shows up in a different color. As you can see, again, we can very clearly illustrate that the balls fall exactly the same in the vertical direction. And we can also show that no matter what the initial velocity is, the balls will hit the ground at the same time. Again, the variables are shown in detail for the balls as they fall. Let's look at the simulation at an angle. This is a multi-purpose simulation that can be used to illustrate a number of principles dealing with projectile motion at an angle. For example, these simulations can be used to discuss and illustrate which angle will give the projectile the maximum height or the minimum and maximum range. Students could be asked to calculate the values for the velocities and distances and then check the answers using the simulations. So let's take a look at the simulation. You can see here we have a cannon which is being shot at an angle. We can set the angle. We can set the velocity. I'm going to set it to 50. I'm going to try to set it to 50. And we can shoot. You have the option to set it either to 9.8 or 10 for the acceleration of gravity. Sometimes setting it to 10 makes nice equal increments, which is easier to show to students. Again, you can show the arrows, not show the arrows. You have the measure bar, which you can use to show students exactly where the balls are at a given time. So let's reset. I'm going to leave that, and I'm going to set trails on in this particular case. So now you see when you shoot, you can see exactly how the ball is moving. I'm going to reset it. I'm going to increase the angle. And I'm going to change the color. Again, I can stop or start the motion at any point. You can see how by increasing the angle that you can show students exactly how the range changes as you change the angle. Let's make this one blue. Notice that the variables are again shown in detail at every instant. Okay, let's go back to the main menu. The third part of the simulation has to do with the monkey and hunter example. There are 3 monkey hunter simulation screens. A cannon is aimed directly at a monkey. The 3 scenes are designed to illustrate under what circumstances the cannonball will hit the monkey and why that happens. It leads students through the explanation of why the cannonball will hit the monkey, first by taking measurements from the simulation, and then by showing how the vertical distance of the dropped and shot balls are determined by the equation y equals VIT plus 1/2 AT squared. So I don't want to spend a whole bunch of time on this, but I'll just quickly run you through the screens. Here is the monkey, of course. Here is the cannon, which we'll be shooting, and we can change the initial velocity. You can see that no matter what velocity you set, that the shot, if it's aimed directly at the monkey and the monkey drops, the shot will hit the monkey. Now, we could leave the monkey stay there, in which case now, of course, even if you're aimed directly at the monkey, you will not hit him. And you could say, what if there was no gravity? And here it doesn't matter what the velocity is. If there's no gravity, the ball will go exactly in the direction that we shoot it and will hit the monkey. So here you can illustrate exactly what happens in this very, very well-known demonstration. Let's move on to the Monkey Hunter 2 simulation. In this case, we'll want to stop every 1 second, show the trails. We will shoot, and in this case, the distances and time are set up so that the monkey will be hit exactly in 3 seconds. And then by clicking on the show guides, you can see that we will measure the distance that the monkey has fallen to show what the ratios are. And we can use the measure bar and the distance to calculate out exactly what those numbers are and then type them in. Finally, in Monkey Hunter 3, we will take those numbers and then illustrate exactly what these guidelines are saying, and that is that there is an initial velocity and then there's an acceleration, and the combination is what causes the monkey to drop exactly the way it does. Now, as I said earlier, there is more information included for each of the simulations. There is a Word document that talks about the controls, the variables, questions that you might ask, suggestions, other resources like Mythbusters video that might be helpful, screenshots, and so on, so that you know that you've got plenty of information in order to use these simulations. So thank you for watching the Multimedia Science Projectile Motion SIMS video. If you're interested in the product, please go to this URL at Teachers Pay Teachers. It's a well-used, well-tested product, and I found it very useful with my physics classes. Thank you.